At this very moment, we find ourselves confronted with the most up-to-date and recent developments in the field of drive technology. Beside me, our product expert, Ralf. Thanks for being here, Ralf. Let's get to the point. Many massive changes in the field. What kind of system are we seeing here now? It's ultimately about implementing a project in the field of drive technology, right?
That's right. We have redefined protective technology here. Okay? That means protective technology is an old topic, which is still included in the curriculum. And now we really want to make a project approach here. Means we have picked up a project of a grain drying plant here, just to really show a project idea protector. Let us enter this place and observe in detail the demonstration of this grain drying system. It will be shown to us gradually, with each step carefully explained and demonstrated.
From the outside, it looks like you have invested a lot of time to create these 3D animations very elaborately. Well, that looks really appealing.
Indeed, we have invested a substantial amount of time in order to complete this task, with the primary objective of ensuring clarity for students or learners regarding the functionality of such a system. Here we have the fan now, then it basically continues.
So we are truly going step by step here, and the learner simply gets to know how this entire project setup is structured and organized.
Exactly how the entire project is structured. Then comes the next step, which means you can also operate them. And thus, this system is constructed gradually, one step at a time. Here you can also see how it works. Currently, grain is being filled. That looks very good. Also stirred, that means we examine it in a step-by-step manner.
If I now mention the term digital twin, what role does it play here?
We will come to that in the next step. Here it is now explained how it works. Okay. And then we also have a closer look at the digital twin in a subsequent step of our analysis process. Maybe turn on one more. That means we would turn on the ventilation and turn on the heating now.
And does that dry it in the end?
Exactly, dry. Okay, so we get good beer, which tastes decent. Principle understood. That means now to the digital twin. Exactly, that means we have modeled this system again as a digital twin. That means here we have the facility again, where we can really walk through it. That means we're going into the facility and can essentially have control over this system as well.
So a complete 3D model of the entire system, including the function.
Exactly. That means here I can also try as a student, how should the system work? I can comprehend that exactly. That signifies I need to ponder the workings of the system in order to understand it. And then we take it a step further and look at what are requirement profiles. What do I have to do? To control the filler accordingly. What actions should I take for the agitator?
And then the hardware comes into play?
Then, of course, the hardware comes into play.
So we begin in the digital realm and then transition into the physical world by implementing subsystems in the hardware components.
Of course, we want to implement subsystems in the hardware because we naturally don't have the grain silo. And we just want to see how to connect the shooters accordingly in order to operate the overall system accordingly. That signifies I subsequently generate a streamlined requirements profile for each separate sub-project in order to ensure efficiency and clarity throughout the project lifecycle. Here we have the agitator. It will only be turned on. Then we have a topic of self-maintenance, and then you can basically see what the self-maintenance system does. And here is also a corresponding circuit sim.
Also an e-learning training module.
Precisely. Which then enables you to construct the system in the circuit simulator, so to speak. That means here I rebuild the circuit again and then just let it run.
That means we can build the circuit in this simulator, as the name suggests, and then simulate the function? Exactly.
I am going to make it super easy for myself now. I will just load a sample in the meantime. That indicates I will examine this self-holding, and here I possess the self-holding currently, and now I click here to turn on the feature. Okay, then we observe. You can see how it works. Amazing. When turning off, it's the same.
All right, that is understood. So this is truly a very, very comprehensive course that we have. And now he proceeds step by step through all sub-projects.
Through all sub-projects. One of the last is star delta starting. I'm going all the way to the back, a highly recognized and widely discussed subject. Therefore, once again, presenting corresponding sound plans and also showcasing the hardware involved in the construction on a full screen display.
And here I can see all my devices in 3D. That means we have a complete 3D model of the experimental setup. Yes, my coworker, do we also see in this model how we must wire it or how the learner has to wire it?
We also see that. Once more, as info, the flaps at the rear are error switches, meaning troubleshooting is integrated here. That signifies we can additionally construct errors for the student or trainee, which are fundamentally encompassed in the circuit.
Okay, that's exciting. That means here on these modules, there are fault switches at the back.
Exactly. That means before I hang them on the wall, I activate errors, let people work with them, and then basically they also have to get the whole system running. Impressive, very beautiful. So, and now I want to wire the system. Here I have the additional option to see again how the cables need to be laid through my 3D animation.
And even if the cables are stacked on top of each other, we can now see how easy it is to recognize how we need to wire here. So the 3D animation here is really an added value for the learner and also simply reduces the time to implement this structure correctly.
Correct. Usually it should be the case that the trainee is able to handle the sound plan, but frequently it is simply not the case. The story in 3D format, where we can visually depict how it is wired in a three-dimensional space with depth and perspective, simply enhances motivation, prevents errors, and so on and so forth.
Great. And if we currently desire to connect the digital world with the real world, so to speak, the extended reality, then we arrive at this system, correct?
We were already at a point here where we had our silo in a digital replica. What we haven't had yet is this digital twin interacting with our external world, and now we come to the system. Marvelous.
That means, do you have a conveyor or what's here?
Exactly. Here we have a recycling plant, and in this recycling plant, concrete stones are basically shredded. Yes, it also has to be done. That means here we now have a complete model of this recycling plant, in which I can also move around relatively freely. And here we now basically see two different conveyor belts, each with its own motor. And I can now control these engines in this case. Are they controlled here via the frequency converter?
That means the electric motor we see outside drives one of the conveyor belts, so to speak.
The engine is exactly the engine that is here now. The one in blue, okay, all right.
That signifies if I deactivate this engine at this moment, will we witness the engine slow down at this juncture in time?
The engine is slowing down, and we also see that the front belt is standing still at the same time. That means now the tape will continue to be loaded, but the system is standing still.
He is commencing once more. He is engaging and running once more.
It starts again, and the virtual world actually responds to the actual speeds of my engine in real time.
What about torques, for example? So the more mass I have on here, the more force it requires, and then the electric motor has to provide. Yes. Can we also record any curve or similar here?
We can also do it. On one hand, I have the ability to control the inflow of my recycling material.
What do we have here? The amount and the weight. These are the things that exist in this particular place.
Also, how big the stones are. I have made them really big. That means they are also visually represented as much larger. You can see that directly, clearly, wonderfully, and can then demonstrate how it reacts. Can I even modify the coefficient of friction? Exactly. I need to demonstrate the construction of the belt, and in doing so, can alter the coefficient of friction. If I perform these actions now, I will enter the nearby canyon, allowing me to record it using my motor vehicle as well. At this particular juncture, we are now able to perceive it. Yes, okay. The current visual representation is like this because it is coupled with the inverter, and the subsequent step in the process is that after the canyon recording, I switch back to my system and ultimately ascertain the precise operating point in my system.
That sounds exciting, and despite being a huge facility, we can still implement it here in a compact format with the real hardware because we use the digital environment here, or rather the 3D model. That is accurate.
At the present time, our entire system is missing. At this moment, we have to empty the system again so that we can start over from the beginning.
That means the system can be so full that the electric motor can't handle it anymore. How in reality?
Like in the real world. Now we can also see that the operating point is returning to where it should be, and then it basically stops. Here I can see where the operating point is moving. That means if I empty my system again, then he also moves. Everything in real time. Everything in real time, where we really have the digital twin in extended reality and can work with it.
Wonderful. Thank you very much, Ralf. I think this is a super exciting and interesting system that really brings together the digital world and the real world here and both interact with each other.